Hi, welcome to the video series on energy. So I'm going to solve some extra problems from our work energy section of our class. So this is the flight attendant problem where we have this flight attendant, as you can see, and what we're going to do, let me just move this out of the way, is solve for work. So she's pulling this at some angle along a certain distance. She exerts a force. What work does she do in the flight bag? What work is done by friction? And what is the coefficient of friction? So here we go. So what is the work she does on the flight bag? So let's take a look at the free body diagram of this. So we have the object like this. It's being pulled at some angle. We say it's 52 in this problem. Like that. We know that this force, she pulls her flight bag with a force of 40 newtons, like that. There we go. We know friction's involved, so that's there. And then we have the normal. Okay. So, let's see. So A says work done by her. So work done by the, call this applied. Work done by the applied force, which would be force applied times the distance. Now, as you can see, this thing is going to be moving a distance of, I'll make it like that, 253 meters, like that. So our work, by definition, times cosine of our angle between the force and the distance. So her force applied is 40 newtons. The distance is the 253. That's how far she went. And the angle between the force and the distance happens to be 52. So this is going to be a cosine 52 degrees, like that. And just as I calculate this, remember that we always find the force that's along the direction of the distance. So notice that we're finding basically Fx right here, and then corresponding to that. So when I do that, I get 6230.49 newtons. So that will be our work, sorry, not newtons, it's an energy, so it's a joule. My apologies, joules. So that is the energy or work associated with her pulling her flight bag right here. Let's do the work done by friction. So the work done by friction will be the force friction times the distance that it went times cosine of the angle. So here we go. So we see a key word, which is constant velocity. Which means, if it's constant velocity, that means the sum of the forces, so constant V, means the sum of the forces, specifically the x direction, is going to equal to 0. Or in other words, that our force friction is going to equal our force applied in the x. Or another way I could write this is through this expression, which is force applied in the x minus force friction, will give us no acceleration. These both mean the same thing. So with that said, I can find Fax as doing Fa times cosine of my angle. So I could find the frictional force. So that's going to be 40 newtons times cosine 52. Gives me 24.63 newtons, like that. Okay? So the work done by friction is going to be the force of friction, which is 24.63 newtons. Sorry, my computer is glitching for a second. Hold on, there we go. Okay, so we found the force friction. Great. Now we're going to multiply by the distance, the 253 meters. Oops, it's 23. times cosine of our angle. So if you take a look here, the angle between friction and distance, I'll just draw a visual right here. Here's the distance. It's going this way. Friction is going that way. So the angle between these two is 180. Or, as you can kind of see what we're getting at, is this is going to be negative. Because cosine of 180 is negative. So we get negative 623.49 joules. So it's negative because we're doing work against. So you might say, oh wow, that's the same as this. So what's happening is that the work applied and the work of friction are the same, and that's actually not coincidence because this has to be true. It's that the velocity has to be constant. So what this basically says, if I were to add up these two works, this plus this, you get no work, there's no energy in the system. In other words, it's keeping its motion. And I'm sorry, since it's keeping its motion, there's no extra energy. We're not changing its velocity. Therefore, we say that the system doesn't change its energy. So let's take a look at the last question, the coefficient of friction. So now that we have the frictional force as 243.63 newtons, what is force friction? Well, force friction is force normal times mu, which means we not have to figure out force normal. So this is more of like a Newton problem. And then as you can see, we have to take a look at the y directions because we see we have 3 forces in the y. So it's not okay to say a force normal is equal to force gravity because we have this additional force. So what we have from that is force normal minus the force of gravity, but we're going to add the pull from the applied force right here because we're lifting a little bit, which is why this is up or positive, which gives us that force normal is basically going to equal to the weight minus FAY. So notice I moved that over and I added it and then subtracted it. So with that said, force normal, by the way, we need to find this to find that. So force normal is going to be mg, so that's the value of that, minus FA, sine of our angle, which will be, so if we look in the problem, we have this number, which is actually equal to Fg. That's the weight of the object. We don't have the mass. So we could just plug that in. That's because it says newtons. If it said kilograms, we have to multiply by 9.81, but since it's not, we could leave it as 70. Minus, this was what, 40? Yep, 40 times sine 50, was it 52? Let me just double check. Yeah, 52. Oops, sorry. Come back. Perfect. So, 70 minus 40 times sine 52 gives me 38.48 newtons. And as you can see, the floor doesn't have to push as much because we're being lifted a little bit with that force. So, we have force friction, which is the 24.63 newtons. We have the normal force, which is the 38.48 newtons. We could solve for mu. Okay, now that I'm solving for mu, I get mu. So I divide, yeah, I'll show you the step actually, I won't jump my algebra. So to get mu, it's going to be 24.63 newtons divided by 38.48 newtons. That's mu, where we get mu is equal to 0.64 after we do our math. So that is it. So we can find the work done on our situation, and we found the coefficient of friction. Stay tuned for our next video.